And now finally we can start creating some renders. So we will start with the ground geometry first. And if we remember, if I go up a level, we already have a geometry container here which has our R&D ground, and this is what we will use to render the ground geometry. And in the downloads you will find a folder with our texture, which is going to be this folder ground dirt, and from here we will use all of these textures to generate our material. So going back to Houdini, let's create a new paint tab over here and set this to be our matte context, so the material context. And in here I will drop down a redshift or an RS material builder, and I will rename this to ground and step inside. So let's import our textures. I will drop down an RS texture node and let's bring out the parameters by pressing P, and let's point to our albedo. So from where you have placed your folder with the texture, you can import the albedo first, and I will set the color space to this to be auto. So this will be my albedo. Let's copy this node over and let's import the roughness. And this color space for the roughness should be set to utility. Let's find utility and raw. And let's rename this to roughness. And also I will duplicate and import my normal map. And this should also be a color space to utility raw. So here it is, utility raw. And let's plug all of these into their respective slots. So for my albedo, I want to plug this in the diffuse color. The roughness will be inside the reflection roughness. And for this bump map, and this can be renamed to normal, let's plug this first into a bump map node. And I will set the map type here to tangent. And we want to place this inside the overall and bump input. So over here. And this should be fine for now, so let's go ahead and grab this ground material, go to my object context and assign this material for the R&D ground node. So place the material here and let's place a dome light, so RS light dome. And for the texture, you will have to look inside the HDRI folder where I placed the sky HDRI. And this is a very simple sky that I got from Polyhaven, and I will also provide the link in the links file. So select the HDRI and place it inside this texture slot. And we can also preview this in our viewport. And we can see that it's just a very basic sky texture. And most of the coloring we will do inside of Nuke, so we can use a very simple light setup. So let's go back to the camera. And before we start doing some render tests, we can see that if we go inside this ground geometry, let's step inside here and let's check this information for the object. We are still having some packed fragments. So let's make sure that everything is unpacked and we are working with actual geometry. So let's go back and let's go in our effects. Let's go to the transform pieces part over here. So our R&D ground, this is the node that we are importing inside that separate object. And we can see here that these debris rocks that are outside of the simulated area, these are still packed primitives. So we can drop down and unpack over here and also unpack these. And now if I go to my raw R&D ground and check the information, we are no longer working with packed primitives. So let's go up and let's go inside the geometry. Now we see that we have 4 million primitives, and this will be rather heavy for a redshift. So what we can do is we can save this geometry as a redshift proxy, which will essentially convert this geometry into a redshift format. And then at render time we won't have to wait for Redshift to convert the geometry each time we try to adjust some settings and rerun the renderer. So let's go back up and let's go to our effects, to our transform pieces. And also here after the merge, and let's get rid of the low quality one. So after we merge the simulated pieces together, we will want all of these to have a rest attribute as well. So let's drop down a rest position and let's store the rest and also use rest normals. So inside the material, inside this ground material, we will use a triplanar node. So I will drop here an RS triplanar. And with this node, we can skip giving the pieces a UV. So this node will take any texture and it will map it on the geometry automatically by using a triplanar projection. And in order for this node to work, this will look for a rest attribute for the position and also a rest attribute for the normals. So over to my object context, we will need rest for our pieces, and this is before we transform them by using the simulated points. And then also, because we merge this with the rest of the geometry over here we will also need a rest. So I will just copy this node and also make sure that the outside of the geometry, so the non-simulated geometry, also has this rest attribute. Okay, so our pieces have one, and then the exterior geometry also has a rest attribute. So this will be very important. And so over here I will drop down a redshift proxy output, and we can use this node to convert this geometry to a redshift format. And so let's set a render frame range for this. And if I preview this render ground, or rather we can go to our simulated points, and we can remember that we forced these points to kind of stop early. So if I play the simulation, we can see that these are simulating up until frame 100 and I believe 40. So we can see here that this final point kind of stops moving. So every point stops moving at frame 140. So we only need to cache this range up until frame 140. We don't need to cache it all the way up to 200. So inside here I will set the range to be 1 to 140. Inside the redshift tab I will leave these settings by default, so we don't need to use motion blur, and go to the archive. And for the saw path I will grab this node over here and I will paste this here. And now let's select a destination. So let's go ahead and select a folder. So this will be my destination. I will place this inside a folder called rs ground, and the name will be rs underscore ground dot $f4.rs. So it's very important that you include this $f4 and .rs syntax, so we can ensure that they are saved into this rs format and each frame is cached. And before we hit render here and save the geometry, let's maybe optimize this a little bit, and right before this RNDR ground null node, let's drop down an attribute rename, and let's only keep the attributes that we are interested in. So for this I will want to, let's get rid of this, and I will want to keep, let's say, our rest and our rest normals, so this RNML vector. So these are our rest normals. And now over here for our proxy output, let's disable this option here where it says discard the not used attributes. So this will ensure that our rest position and rest normals are going to be saved with the geometry. So now I will hit render to disk.